Hi everyone, this video is on exercise 9F, question 9 parts E, F, G, and I from pure 2. So I skip H just because it's very similar to the previous examples I did in the last video. For example, it's very similar to part C. Just, you have R cos and that's X squared. So it's just very similar. A quick recap. So in the previous video, one of the previous videos, I showed how to directly differentiate inverse trigonometric functions. But in the previous video and in this video that I'm about to solve some examples, I'm just going to use the standard results. So this is the way that you sort of memorize the results and you just recall them in the exam and use them. So last time we worked on arc sine, arc cos, arc tan, and arc cot. So in this video we have two more results. So the first one is E, which is arc sec x, and this is again one of the standard results, because if you want to differentiate this, so the derivative is basically going to be, so dy du is equal to, it's u dash over modulus of u times square root of u squared minus 1. So this is the result for arc sec, which is sort of similar to the previous ones, let's say to arc sine, but obviously we have an additional term which is modulus of u in the denominator. So let's see how we can use this. And of course in the denominator this time you have u squared minus 1, whereas in the previous one, which was for arc sine, you have 1 minus u squared. Anyway, it's enough going back and forth. So we want to differentiate this. Remember that here u represents the function inside the sec. So in this case sec is just x and the derivative of x is 1. So u dash in this case is just 1. So that means dy dx is equal to just simply 1 over 1 times square root of u square root of u squared, which is u in this case is x, x squared minus 1. So it's always good to just write down, for example, u in this case is x and u dash is 1, so it's you can keep track of the functions that you have. Right, part B, part F. So we have arc cosec x, and you might have already guessed that, because in the previous video when we showed different trigonometric inverse functions, for example, when we have arc sine, we could easily build arc cos from that, because it's the same as arc sine, but you just have a minus sign, it just negated. And this was also the same when we had arc tan and arc cot, where the arc cot is the same as arc tan but negated. So same thing applies here. So for arc cosec, the derivative is the same as arc sec but negated. And the good news is this makes your life easier when it comes to memorizing, because this means instead of memorizing a new result for each function, you only need to memorize one result for a pair, for a similar pair. For example, one result for sec and cosec, and just remember that for cosec is negative of sec. So in this case, again, u is x, the function inside, so u dash is 1, and therefore the derivative is equal to minus 1 over 1 times the square root of x squared minus 1. Okay, sorry, I made a mistake. I just realized that. So I made a mistake both in here and here. basically, according to the formula, we have the modulus of u. In this case, u is x. I accidentally just considered that u is 1. So yeah, here we should have had modulus x, not 1. Yeah, sorry about that. Because we should have the modulus of the function, not the derivative. I accidentally thought that's the modulus of the derivative, and the derivative is 1. So that's why I wrote 1. But it's actually the derivative of the function, which is x. And finally, g. So, oh, we have one more, which is I. I forgot about that. So g is more interesting because we have the function x over x minus 1. And first, let's differentiate the inside function. So u is equal to x over x minus 1. So this is a simple quotient rule differentiation. U dash is equal to the denominator squared, and then the denominator function times the derivative of the numerator function. So numerator function is x and differentiates to 1 minus, now it's the numerator function times the derivative of the denominator function. X minus 1 differentiates to 1. So if you simplify this, you basically have x minus 1, just expanding this, and the result is minus 1 because the x and x minus 1 cancel out. Then the denominator is x minus 1 squared. So that's the final answer for the differentiation of the inside function. Now we need to use this in order to write down the derivative of arc sine. So dy dx is equal to, just to quickly remind you, when we have arc sine, we have the derivative of the function in the numerator, and then the denominator is square root of 1 minus the function squared. So in this case, the derivative of the inside function is minus 1 over x minus 1 squared. So that's the derivative. And then here we just have the function squared, sorry, 1 minus function squared. So 1 minus function is x over x minus 1. So whenever I say function, I just mean, the inner function that is inside the, the trigonometric function. So this is the final answer. We can simplify this, but I will just leave it in this form. Just a quick recap. We first found the derivative of the inner function, which needs a quotient rule, and that's minus 1 over x minus 1 squared. Then I just use the standard result of arc sine, which is the derivative on top over square root of 1 minus inner function squared. And finally, for part I, we have e to the x times arc cos x. This is a product rule. So as usual, dy dx is equal to, so in product rule we can do the first function times the derivative of the second function plus the derivative of the first function times the second function. So the derivative of the second function, which is arc cos x, is just minus, it has a negative, so it's the derivative of the inner function on top, which is, we show that the u dash, and then the denominator is 1 minus the function squared, 1 minus u squared. So in this case, just substituting these values for u, u dash is the derivative of x, which is just 1. So that's 1 here. And then u squared is just, the function itself here is x, so it's just x squared. And for the second part of the product rule, we find the derivative of e to the x, which is the first function, and e to the x differentiates to e to the x, times the second function, which is arc cos x. And yeah, so we can factorize, take a factor of e to the x, and it's going to be arc cos x minus 1 over square root of 1 minus x squared. Okay, that's it for this video, and thank you for watching.